Hi! This video is part of a build log series where I'm building motorized shoes that you'd wear while you play a VR game. The shoes will keep you in the same spot in the real world as you walk infinitely in the game. The shoes are this. This is the current design. It uses omni-directional wheels so that you can turn and walk in any direction and you'll stay in the same spot, and even strafe too. And in this video, I'm going to go over the progress I made over the last 2 weeks. Last time I showed how the gears in my gearbox were skipping when I put all my weight on the shoes. You can see here that if I grab the wheel with my hand and turn the motor on, the gears skip. I also had a problem where the rollers on the omni-wheels were breaking and coming off of the wheel. So let's go over how I'm going to solve these problems. In the last video I explained that the rods that are going through this gear and this gear are not braced on this side, so they can come apart a little bit, which causes some skipping when the motor and the teeth and the wheels are under a lot of strain, under a lot of weight. So I've redesigned the gearbox so that on this side, the two rods are braced so that they cannot come apart at all. There will be 2 bearings on this side, and I have all the parts printed and it's ready to go. I'm going to put it together. Here's the new gearbox that's reinforced on both sides. There's 2 bearings on this side, as you can see, and there's 2 bearings on this side. So now the 2 rods, they're in this one piece and supported by the bearings, so they can't come apart at all. So that means the teeth won't skip. And it's braced on both sides like that, so the teeth won't be able to come apart on either side. To fix the problem where the rollers are coming off, I'm just going to try to use more glue. See, the roller is in 3 parts and the outsides kept coming off. I only used a couple dabs of glue to hold these on. I'm going to glue around the whole perimeter of the bearing so that the bearing is really attached to these rollers and shouldn't come off after that. After making those changes, I did more testing. At first the wheels wouldn't turn at all when I put all my weight on the shoe, but the teeth didn't skip either, so the motor was just stalling. I was partially happy with this because it means the teeth weren't skipping anymore, and my fix worked. I then increased the power of the motor to the shoe and it was able to move me. However, the omni-wheel rollers still got damaged and even the frame of the omni-wheel broke in one spot, as you can see here. So the omni-wheels need some redesign. I experimented with a few different designs that you can see here. These designs had backings on them in order to increase the strength of the frame so it wouldn't break under the strain, but this ended up making the omni-wheels really wide, so wide that I would need to increase the width of the platform to about 9 inches to fit everything underneath of it, but I wanted to keep the width of the platform to 7 inches, so I didn't go with these. This is the design that I'm going to go with, I'm going to try next. It looks similar to the other design, but it's actually different in many ways. First, it's bigger. It's 2.5 inches in diameter instead of just 2, and with that extra space, I was able to do a lot up here. Before, this bearing here, this is a bearing, it was in the roller on the end here. I moved it into the frame, and then in here, this is just an embedded screw, or I'm sorry, an embedded nut, and the screw just screws on the end here. So this is a screw, a headless screw, that just screws into this nut. And I'll use some thread lock to make sure that this stays in place. And that screw goes through the bearing, and the bearing's in the frame here. I had to increase this width by a little bit, which made the frame a little stronger, but also this bearing can't come out because if it tries to move to the left, there's this material here. If it tries to move to the right, then all this other stuff over here is going to prevent it from moving to the right. As you can see, there's this material here that will keep everything from moving to the right, and the material here that will keep everything from moving to the left. So you can see that this roller assembly, it's still in 3 parts, but now it's much more secure. There's no adhesives that it relies on to keep the bearings in place, and when everything's screwed together, it shouldn't fall apart and it shouldn't break like it did last time. If you're wondering how I'm going to embed the nut into the end of the roller like I showed, there's a trick that I'm going to use that's available in Prusa Slicer that's really nice. Here's how the printer is going to print the end of the roller, and you can see in here is the hole that the nut should go in. Prusa Slicer has a feature where you can go to the layer you want, so I'd go right about here, and you can add a pause. So you can add a pause to the print and say, place nuts in slots and resume printing, and then it will pause the print there, and I'll be able to put the nut in, and then the print will continue over the nut, and the nut will be embedded in this part. So here's the frame printed out. I printed the two halves together to make it stronger. You can see that the arms here that I call them, these parts that stick out, they're fused together now, so they help reinforce each other a little bit. And to show the strength of this, I took a pliers and I gripped right over the hole where the bearing goes. Put my pliers right over that, and then if I squeeze, I can't break it. So it's pretty strong. I think it'll do the job. Here's what the drives look like now after redesigning them to support the larger omni-wheels. I increased the gearing in here a little bit. It before was a 2.25 to 1 gearing ratio. Now it's a 3 to 1 gearing ratio. And the platform is still the same width and length. There's just a little bit on the other underside that is cut into a bit. You can see here that there's a bit on the underside that's cut in so that these wheels can fit. But I didn't have to increase the height by very much, only 0.002 inches, I think. And yeah, so the design is ready to be printed out again and put together. Now I know I look funny here, but one last thing I wanted to mention is the shoe does not tip. I'm trying to get the shoe to tip over by leaning one way or another, but it doesn't tip over, because if it could, then that could lead to someone rolling an ankle. The platform, the top of the platform is 2.75 inches off the ground, and you can see it still is completely stable, which is really good. Now that the redesign is done, I'm going to start printing out all the parts. I've started printing out a few, and I'm going to put the shoe back together with all the new parts. So I'm gonna have to take this whole thing apart and put the new wheels on and the new gears and all that stuff. So in the next video, I hope to have all of that together, and we'll do some testing. And then maybe, if I'm happy with it, I'll start making the second shoe. So if you liked the video, make sure to leave a like, comment, and subscribe. You know the deal. And thanks for watching. I'll see you guys next time.